All right, so different venue. We're actually in my basement, and I'm gonna start building aero components. So first thing is like a little mini series of basement composites, and yeah. So the first thing, I made a CNC hot wire cutter out of spare 3D printer parts, and this is the end result. So I tuned it to match the 3D printer profiles because these are going to be printed for the end, like the end condition, so I can insert like threads and stuff like that to bolt on end plates for a wing. So I tuned the printer to match the 3D printed, or not the printer, I tuned the hot wire cutter to match the printer size. So because it's cutting with heat, you don't actually want to trace the exact dimension because it'll be undersized. So you have to kind of tune it to match. But yeah, so I'm gonna go over how I basically turned a garbage Ender 3 3D printer into a CNC hot wire cutter. So stick around. Also, I would really appreciate if you guys subscribe to the channel. I'm trying to hit 1,000 subscribers by next spring. So if you made it this far, hit the subscribe button and then let's go. All right, so basically these are the 80/20 rails or 20/20, whatever dimensions they are, out of an Ender 3. There is no brace across to either side. They're just bolted to the table. And this table is 4 feet wide, so the cutting is a little bit under 4 feet at about 46 inches. Now, if you're familiar with Ender 3s, this kind of assembly should look pretty familiar. This is one of your Z height axes. This is your Z lead screw, and this is actually the Y gantry. No, actually, it's the X gantry. So using this piece, which is usually where your hot end attaches to, I just bring it up and down. And basically what I did was I took this, I mirrored it on this side. So this has some 3D printed brackets that I ended up attaching everything to. This is a dual Z lead axis kit off Amazon. I think it was like 20 bucks. So the one thing I was concerned about not having a support across the top was the rigidity of everything, but it's actually fairly rigid, and you have to keep in mind I'm only doing this for 2D wing profiles for basically aero components. So the cutting range is actually only probably 0 to 3 inches because I'm never going to have a wing profile that's taller than that. So the rigidity up here is way less important than the rigidity down here. And down here, this thing is rock solid. Plus, even if it does go side to side, you have to have springs to take up the expansion of the nichrome wire, which runs across. So I'm assuming if you're looking at this and you're wanting to build a CNC hot wire cutter, you probably have access to a printer, which is what I printed these little brackets on. So these just kind of, they bolt and marry up with the existing Ender 3 components. I reused the bolts, reused just about everything. The only thing that had to be printed was this, because you have to invert this side to make the axis bracket work. So you have to 3D print 2 little components. Yes, they're not super rigid, but they do the job. It doesn't have to carry a bunch of load, it just has to go back and forth. So with that, this is actually the Y pulley system, and I just kind of jerry-rigged it on, clamped it down, and there's some extra belt. So everything from the various pulleys for the Y-axis, the X-axis, the lead screws are carried over, that's the original one, and this is an add-on dual lead screw kit, and even the belts. So this is the Y-axis belt, and this is the X-axis belt. This gantry basically came right out of the printer, and I could almost bolt it in just like this, and it works great. So now, how do we control it? Well, that's what this little guy is. There's nothing special about this. It's literally an Arduino with a CNC board on top of it, and I'm only using 2 stepper motors, or not stepper motors, stepper drivers, 1, 2, and then they go into splitters. So these little splitters take the signals coming out, split them to 2, so each signal is split side to side. They get the exact same signal, they move the exact same amount. Now, if you wanted to do a 4-axis hot wire cutter, You would have to populate both of these with stepper drivers, and you wouldn't need these, but I just wanted to make it as simple as possible. This is the first time I've ever used one of these boards, so that's how we did it. And let's not forget the power supply of the printer. This is what's actually powering the nichrome. So you need to have a power supply to basically feed current through a nichrome wire that then gets hot, and that's how it actually cuts the foam. There's no abrasiveness, it's only heat that cuts the foam. So that's just kind of a quick and dirty overview of how I built a hot wire cutter, CNC controlled, runs a Gerbil software on my laptop for maybe 70, maybe 80 bucks, definitely less than $100 because I picked up a broken printer off Facebook for 50 bucks. Dual lead screw kit I think is 20. Arduino kit, maybe 15, 20, and some stepper motors and drivers. All the stepper motors, you only need 4. There's 4 in a printer. It worked out really, really well. So that's just kind of the intro to the series where I'm going to be using it to cut wing profiles for the rear wing, some dive plane canards for the front, where I basically will build them out to the width of the splitter, bring them back to the car, and then after that, we have the rear diffuser, which is going to be a lot more involved and a lot more complex, but I think we can make something really cool here. So if you want to see how this turns out, don't forget to subscribe, like, do whatever the normal Facebook things or normal YouTube things are. I can stop tripping over my words and act like a professional, but we're not professionals. That's the point. So we're here to teach each other. So until then, see ya.